You say it was 16. Oh, but she just texted it at 7:30.
Morning. There's a big old wreck up by where I live. I added about 10 minutes to my drive, so sorry I'm late. All right, next thing. Oh, next thing. If someone's talking to me, I can barely hear you. So let me see what I can do about my volume. Okay, try again.
Morning.
Morning. I can hear you fine. Do this. So I can do this. And it's not responding. Oh, no, it's almost there. That's what I wanted anyway. There we go. So what I'm doing now, I'm getting my thumb drive so I can pull up the review sheet. And here we go. Oh, wow, no kidding. And there. And I can't do anything about that. But I'm pretty certain. There, can you read this stuff? Yes, no, maybe so. I gotta pull my Zoom thing up so I can see you. Whoops, there we go. Oh, yeah. Unless you have a real tiny screen, like if you're looking through your phone, this should show up fine. Yeah, this is basically the layout of the second exam. So yeah. So what problems do you want me to go, do you have questions about? Because as I explained earlier, I will not go over these. I will only answer questions about them. Your task was to open this file up and work the problems and come to class today with questions. So ask away. Tell me, all right, there's 24 questions on this review. There are 14 questions on the test. I've already created the test. In fact, as I was done creating this, I created the exam. Either it's going to be a long silence or because I'm just going to respond to y'all's questions.
Professor, can you do number 17?
Number 17. Let's see what number 17 asks us to do. I'm digging out a pen. And I'm going to get more things. Okay, number 17. So we want this to end up looking like this. Okay, so you got well, I don't know which side is the more complicated one, because you don't have to start on the left-hand side all the time. But I know double angle theorem. Double angle formula for sine. So you have access to that worksheet that I posted. Download it, print it somehow, so you can use it on the exam on Wednesday. That sheet of formulas. So the sine of pi over 4 plus x will equal, isn't it sine, sine, cosine, cosine? Yeah. Sine's the easier of the two. Sine of pi over 4 times the sine of x plus the cosine of pi over 4 times the cosine of x. Well, right away, I see how this is going to work. Because what's the cosine of pi over 4? And what's the sine of pi over 4? My only question is, wait a second, am I remembering the summation right? Sine of the sum? Will that worksheet? That formula sheet. All right. All right. Yeah. Oh, it's sine, cosine, cosine, sine. So I remembered it wrong, which is why. Oh, that doesn't help. There we go. So it's sine, cosine, oh yeah, cosine, sine. I was wondering if I was remembering it right, which is why you have a formula chart that you can use. Okay. So what's the sine of pi over 4? Is there one of the first quadrant angles you should know by this point in time? The first quadrant angles.
Square root 2 over 2.
Square root 2 over 2. So here we have the square root of 2 over 2 sine of x. Bless you. Plus, and what's the cosine of pi over 4? Square root 2, yeah. Cosine and sine at the 45-degree angles, the pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4 are the same, except for the sine, depending upon which quadrant it's in. And in the first quadrant, everything is positive. So. Whoops. What I want to know is what happened to the 2 down here? Because I can factor out square root of 2/2 out of both of those. But what happened to the 2? What am I missing from the formula? What am I missing from the formula? Nothing. So let's look down here. But no, 17, right? All right, so according to the answer document, I think this is a typo on their part. Because I don't see how they got from here to here. Because here I would factor out the square root of 2 over the square root of 2. So you get the square root of 2/2 times the cosine x plus the sine of x. I don't see how they got that. I think it's a typo. Which happens. Which irritates me. Considering how long this textbook's been out. Is it fine? That's right. Do that, keep that out at home. Hate using their erasers. Okay. Now, on the test, if you made some kind of mistake, and I see this is a mistake on their part. You know, instead of factoring out the square root of 2/2, you all you factored out was the square root of 2 and forgot to write to divide by square root by 2. Then I would certainly, you might lose a point on that, depending upon how severe I felt it is. In this case, that's a transcription error. From my point of view, to go from this to this and forgetting that 2 in the denominator, which is what they did here, that's a transcription error, which is 1 point. So. Number 6, someone asked for, okay. All right, we have 6 times the inverse cosine of x equals pi. But I want it just to be the cosine inverse of x equals to some angle. So I'm going to divide both sides by 6. So I get pi over 6. So with inverse functions, this is only true if the cosine of pi over 6 equals x. The argument of cosine of inverse, is what the trig function gives you. So this is a number between -1 and 1. Cosine inverse gives you an angle. And cosine gives you a number between -1 and 1. And so I'm trying to find out what that number between -1 and 1 is. Since cosine of pi over 6 is in the first quadrant, it's going to be a positive. And what is it? Okay. These angles should have been committed to memory by this point.
Square root 3/2.
What is it?
The square root of 3/2.
Square root of 3/2. Okay, the person who said it in Zoom, if that's what you said, I just didn't hear you. I didn't hear it clear enough. That's why I asked again. Any questions on this? That's pretty much what you're looking at here for numbers 1 through 4. Okay, like on number 3, you divide both sides by -4. So we're looking at the fourth quadrant, and tangent is negative in the fourth quadrant. So whatever tangent of pi over 4 is, it's going to be negative. Okay. Pi over 6 is in the first quadrant, and pi over 2 is in the first quadrant. I mean, that's a quadrantial angle. So if it's a quadrantial angle, the answer is either 0 or 1 or undefined. All right, if it's tangent or cotangent, then it's going to be, let me see. That would be, for tangent, that would be undefined, or it does not exist. So there's no solution here. If we were talking about the inverse tangent equals pi over 2, then the answer is no solution. Because the tangent of pi over 2 does not exist. Okay. On numbers 5, 6, and 7, you're going to be dealing with the same thing. You're going to be looking at a right triangle. Make it a right triangle. No. Kind of a right. There, that's better. Sine. So we're talking about sine of theta equals 1/2. Where 1 is, if this is my angle theta, 1 is the side opposite, and 2 is the, 2 is this the hypotenuse. And so to find this side over here, you use the Pythagorean theorem, and you'll find out that it's square root of 3. And so now we're just asking for the cosine of theta. I don't even need to know what theta is. All I need to do is look at this triangle. Cosine is adjacent side, adjacent leg over the hypotenuse. So this is a square root of 3/2. And that's how all three of these are done the same way. Be aware that we're getting a negative number here. So if we were to do it, so that means that cosine is over here. And so this is where we would build our right triangle. And the 2 is this side, and the square root of 2 is here. And so this also is the square root of 2. And so this will just give us the square root of 2 over 2, which means that that's one of the 45-degree angles. Okay. And I said I wasn't gonna do that, but I did.
Can you get the tangent one?
Tangent one?
Yeah.
All right, tangent is adjacent over, opposite over adjacent side. All right, so it's positive here, so we're gonna be looking at the first quadrant. And so here we have this, and the opposite side is the square root of 3. And the adjacent side is 3. So I want to find the cosine of this angle. So this is the angle theta here. Well, I need to find the radius. So 3 squared is 9. Square root of 3 squared is 3. And I square root that. So it's the square root of 12. And the square root of 12 is 2 times the square root of 3. So this is so we're looking at the cosine of theta here, which is the adjacent side 3 divided by 2 times the square root of 3, and then you need to rationalize the denominator. So you multiply numerator and denominator by the square root of 3. So down here you get 2 times 3, and the numerator you have 3 times the square root of 3. Right? Square root of 3 times square root of 3. Well, that's the definition of what the square root of 3 is. When you multiply it by itself, you get 3. So you got 2 times 3 in the numerator, 3 times square root of 3 in the numerator. The 3's go to 1, and so you're left with the square root of 3 over 2. Yeah, all the angles they're using here are the angles from the unit circle that we deal with. Realize it doesn't have to be that way. Since we don't need to know what the angle is. We don't need to know what the angle is to find this sine, cosine, tangent. Or, yeah. So there was a slide in there, and it's not included on this formula sheet. Is that if you have a right triangle, the opposite side, the sine of an angle is the opposite side being divided by the hypotenuse, the opposite leg. And for cosine of the same angle, it's the adjacent side or the adjacent leg being divided by the hypotenuse. And tangent is opposite leg over adjacent leg. Next. I'm gonna start erasing this stuff. Yeah, I know, I wrote this small. Do y'all need me to write it bigger?
Yes, please, if you could.
Yeah, I just realized that. Okay, so you had the cosine of theta, which was the 3 over 2 times the square root of 3, because of the nature of a right triangle. And the cosine is the adjacent side over the hypotenuse, which is what we have here. And then to rationalize the denominator, you multiply by whatever makes that square root become not a square root. And so you need to multiply the numerator by the exact same thing. So you're multiplying by 1. So again, we're changing what it looks like, not what it is. And so you have 3 times the square root of 3 in the numerator, and 2 times, well, the square root of 3 times the square root of 3, as I explained before, gives you 3. The 3 over 3, well, that goes to 1. So we have the square root of 3 over 2. I was looking at the 2, that's why I almost wrote a 2 there instead of 3. Boom, boom, boom. Okay, so do I need to make this picture bigger?
Yes, please.
Okay. So it was in the first quadrant. And so since it's, which one was it? This one? All right. Tangent is opposite side over adjacent, over adjacent side. So this is the opposite side, and this is the adjacent side. So this is the y value, this is the x value, right? Tangent is y over x. And so, you square 3, you square the square root of 3. You need to take the square root of that. 12 is 4 times 3. So we're taking the square root of 4 times 3. The square root of 4 is 2. And the square root of 3 stays the square root of 3. So this is 2 square roots of 3. So x equals 3. Y equals the square root of 3, r equals 2 times the square root of 3. Cosine is x over r, the adjacent side over the hypotenuse. The radius of the circle will be the hypotenuse of whatever triangle you draw. And yes, this is a 30-degree angle. But you didn't need to know that to solve this problem. All right, any questions from 8, 9, and 10? Eight, 9, and 10, you're rewriting this as a function or an expression in terms of u. So you want to get rid of the sine and tangent, or the tangent inverse. Well, if we look here, I'm going to do one of these, and the others pretty much follow the same path. That means tangent of some angle equals u. And I can rewrite u as u over 1. So that means y is u and x is 1. So I'm going to write my right triangle. Draw my right triangle. This side is u. Well, no. This is not done to scale. So the opposite side is the length u, the adjacent side is length 1. So that means this side is going to be 1 squared plus u squared square rooted. Which is just the square root of 1 plus u squared, because 1 squared is 1. And I can't take the square root of that. So that's what this side is. 1 plus square root of u. Now they're asking me to do the sine of theta, because the tangent inverse of u gives me some angle theta. And now we want sine of that same angle. Well, here I have the right triangle, so I can write that. Well, this is a little tricky here, because you're going to have the opposite side, which is u, being divided by the hypotenuse, which is the square root of 1 plus u squared. And just like before, where we wanted to get rid of the square root of 3 in the denominator, we wanted to get rid of the square root, so we want to get rid of the square root here. We want to rationalize the denominator. So I'm going to multiply numerator and denominator by this denominator. The square root of 1 plus u squared. I know I'm writing small again. All right. Steve Martin had a very clever routine about getting small. So now I forgot what I was doing. Sine is u being divided by the square root of 1 plus u squared. So now I'm going to multiply numerator and denominator by the square root of 1 plus u squared. And all that happens here when multiplying these two together, it just gets rid of the square root symbol. So down here, I'm left with 1 plus u squared. And in the numerator, it's going to be multiplying those two things. So it's u times the square root of 1 plus u squared. I cannot multiply the u directly times the 1 and the u squared because of the square root. U is not being square rooted, so I can't multiply my two things together up here. I have to find out what the square root is first before I multiply it by u, so we leave it that way. Yeah, these get a little complicated because of that, because you're going to be dealing with the square root of 1 plus the square root of 2. I mean, 1 plus u squared. And I think in one case it's going to be 1 minus u squared. But I'm not 100% sure on that. No, it's the same. Wait a minute. Yeah, tangent. Well, with the sine of u, let's look at that. Sine of u, that means the sine of theta equals u, which is 1 over u. I mean, u over 1. So that means in my right triangle, I don't know what I was trying to write there, but it wasn't the right triangle. And if this is theta, my opposite side is u, and that's what that side is. So it's going to be the square root of 1 minus the square root, I mean u squared, sorry. 1 minus u squared. Because we have 1 squared is going to equal u squared plus b squared, whatever this side is down here. So I want to find out what b is. And so I get 1 minus u squared equals b squared. And I take the square root. Okay. And we're assuming all of these things are in the first quadrant.
So like the tan or the sine, right? It's gonna always be u over 1, or is there a difference in?
Nope,
No?
nope.
Oh.
Because you want to write it as a fraction, so you have the opposite side over the adjacent. We wanted to write it as a fraction, so we have the opposite side over the adjacent side.
Oh, okay, okay, yeah.
So we have two sides of the right triangle. In both cases, it's just in this case, it's going to be an opposite side and adjacent side. Here, it's going to be opposite side and the hypotenuse. And if they had, oh, here, yeah. If they had cosine inverse, then the u is the adjacent side. It'd be u down here. So these would be switched.
Oh, okay. Oh, because of how, yeah, okay,
Yeah.
I get it.
Any other questions on this? Now, once you understand how to set it up to find the answer, boom, it just falls into place. We still haven't found the answer here on this one, right? So now we want the cosine of that same angle. Cosine is adjacent side over the hypotenuse. Well, that's the square root of 1 minus u squared over 1, which is just the square root of 1 minus u squared. And we cannot find the square root of that because it's not a perfect square. I can't take the square root of the subtraction separately. Because this 1 minus u squared is a single number. An example of that is looking at the square root of 9 plus 16. Well, the square root of 9 is 3, the square root of 16 is 4, so that's 7. But that is not what this equals. This equals the square root of 25, which is 5. So taking the individual square roots and then adding them does not give you what the appropriate answer is. So boom, we can't. This is it. We're done. Or if it was subtracted, it'd be kind of a similar deal. Okay. Yeah, teaching about fractions and about square roots and things like that, what you can and cannot do with them. You think by the time a person got to calculus, they understand that. But I've had students in calculus who have the same issues here. It's just, this is bugging the hell out of me. Why someone hasn't taken the time to clean it? Oh, y'all can't see what I'm getting fussy about. There's a small little board over here, another dry erase board off to the side, and it hasn't been properly cleaned in a long time. Okay. Number 9, you just multiply the two together. So you're multiplying a sum and a difference of the two same items together. So you're going to get the difference of 2 squares, which gives you 1 minus cosine squared, which is sine squared. So that one's easy. On number 12, you would multiply it all out and then combine like terms and then move things around so you end up getting 2 times something that equals secant squared. On number 13, I would write cosecant and cotangent as fractions involving sine and cosine. And then write them as a single fraction. and then see what happens from there. Ooh. Oh, because I want to get secant theta plus 1 in the denominator, I multiply numerator and denominator by secant plus 1. And then I multiply the numerator out and see what I got. I would get tangent squared, so one of those tangents would go away with this tangent down here, so that would leave me back. That's an easy one. Yeah, sure it is, Mr. Reed. There are several different ways of doing this. Oh, as a product. So the formula. So this is just directly applying the formulas, that's all. And
Which question were you looking at?
numbers 23 and 24, I'm sorry. Because now you want to express the sum or difference as a product of sines and or cosines. So here I have a sum, so I look at the formula for turning a sum into a product. Here I have a sum and I look at the formula for turning a sum into a product, and I just plug them in appropriately. And same thing with 21 and 22, but instead of going from a sum or a difference to a product, you're going to go from a product to a sum. So numbers 21 through 24 is just simply applying the appropriate formula. So I'm not asking you to manipulate anything, I'm just asking you use the appropriate formula. And then it's just a plug and chug and you simplify if you can. Sometimes you can't, sometimes you can. If you can, do it. If you can't, then you're done. If you can simplify something and you don't simplify it, then that's -2. So just be aware of that fact. If you don't simplify it, you're not going to lose a whole lot of points. But if you get an expression where you don't combine like terms and you don't simplify what you get left over, and you just multiplied everything out and left it that way, or rewrote it as addition or something, and then didn't simplify it, then there might be more points taken off. All right. Now, you look at the formula for cosine of 2 theta. And you write that out. Okay. You write that out. Now, you know what sine is. So that means you can find out what cosine is by writing a right triangle. And since we're dealing with the first quadrant, then everything's going to be positive. Here we're dealing with the second quadrant. So sine is positive, but cosine is negative. So you need to be aware of that. Okay. Cosecant is 1 over sine. So so that tells me sine is 3/5. And cosine is 4/5. I just know this one. Well, I know the 3, 4, 5 right triangle is what I know. And so then in the cosine of 2 theta, I just plug those numbers in I plug them in appropriately in the formula. So it's just a matter of multiplying and then adding. Or subtract, what is it? I can't remember if it was add or subtract. I think it's subtract. But I'm not 100%. Yeah, it is subtract. And again with secant is 1/cosine, so I'm going to convert this to cosine. And cosine's negative in the second and third quadrants. So I'm going to establish that it's, well, and cosecant, we want cosecant to be greater than 0. And so we're going to be looking at the second quadrant, because they think the third and fourth quadrant, we're thinking of negative angles. So, and then you write out the formula for the sine of 2 theta. And since you rewrite this, I would rewrite this as the cosine of theta equals a negative 5/3 square roots of 5, and multiply numerator and denominator by the square root of 5. So I get a negative 5 times the square root of 5 divided by 3 times 5. Those go to 1, so they disappear. So it's a negative square root of 5/3. So the other side is going to be 2. Yeah. So we're going to have square root of 5, 2, and 3. The square root of 5 squared is 5, 2 squared is 4, not 5. 5 and 4 is 9, and the square root of 9 is 3. And so now I know that sine is 2/3, and cosine is 5/3. I mean, square root of 5/3. And so then it's just a matter of plugging them into the formula. And which is 2 times the sine of theta cosine of theta. So we wind up with 4 square roots of 5/9. I think I'm doing all that in my head, so I'm not 100% sure on it. Okay. Number 16 is done pretty much the same way number 17 was done. Because I want to turn these two, this single cosine into cosine minus sine, which tells me I'm going to use the difference formula. I mean the sum formula for well, I'm going to use the formula for the cosine of the sum of 2 angles. Oh, and notice here they have it divided by 2. Where here they didn't have it divided by 2. So Here they did it correctly, here is a typo, so that kind of confirms my suspicion that it was a typo. All right. Number 15 is a fancy way or sort of a backdoor way of having you do a trig identity. They want you to show that those two functions are equal, that f of x equals g of x. All right. So they want you to do f of x equals g of x, which is the cosecant of x times the secant of x, and it's going to equal cotangent plus tangent. Cotangent of x plus tangent of x. Right. Well, I'm going to start with the right-hand side instead of the left-hand side on this one. Because I'm going to write both of these as sine and cosine. So I have cosine x divided by sine x plus sine x divided by cosine x. So, well, if I multiply numerator and to add these two, I need the denominators to be the same. So I'm going to multiply the first fraction by sine over sine, and the second fraction, by cosine over cosine, and the second one by sine over sine. So on the first one, I get cosine squared x divided by cosine x sine x. And the second one's the same thing's going to happen, but I'm going to get sine squared x over cosine x sine x. So my denominators are the same. Cosine x sine x. My numerator is cosine squared plus sine squared. What is cosine squared plus sine squared? Or what's sine squared plus cosine squared? That's the very first Pythagorean identity. What is it? 1. So we have 1 over cosine x sine x. You can rewrite a fraction that has a product in the denominator as two fractions being multiplied. So my numerator, 1 times 1 is 1, so I have 1 over cosine, no. I want to write the secant, the sine first. Sine x times 1 over cosine x. Oops. Boy, that was bad. Typo. I have to be very careful when writing certain phrases, because when I type and I'm typing a T followed by a space bar, very often the space bar comes before the T. And in Twitter, a long time ago, I did a very, very, very bad typo. The space got switched with the T. Yeah, I'm not gonna say what it is, but I got read about it for a long time. Every now and again, one of my friends brings it back up again. Not a very good print, but anyway. But what's 1 over sine? And what's 1 over cosine? Done. So, and what I did was, all I did was switch the sine and the cosine. As far as the multiplying is concerned, just use the commutative property of multiplication. So they're in the same order as what they're up here. So the reciprocal functions come in very handy. So we have cosecant x times secant x. And I think you're gonna have one problem on there like that.
So that formula chart, we can use it on the test, right?
Yes,
And from here, do I have to print it out? The formula chart.
yeah, because I don't have a copy for you.
Oh, yeah, no, that's fine. I was just
You
wondering.
can stop by I think the library lets you print up
Yeah.
things, so. Yeah, if you do not have printing capabilities at home or you don't have access to a printer at home, you can print things up in the library. I don't know, is it free?
I have no idea.
I have no idea. But it's a minimal cost, you're just printing up one sheet of paper. What's been the cat? That cat that's just a year old. She still doesn't understand about claws. She's, well, she must understand, because she doesn't claw my wife like she claws me. Of course, I play rougher with her, and my wife doesn't play with her at all, other than just, she just wants to pet her and be sweet to her. I like to. Well, she likes to play, so I play with her. Her idea of play is hurting things. So. Okay. Did we do other identities? What were the other identities were down here? And I didn't do any of these. Anybody want me to do one of those? From numbers 1 through 14.
Could you do 13?
Yeah, I was just trying to figure out how to do that in my head. I was hoping someone would ask that. Okay. So do I want to start with this side and see if I can make it more complicated like this side? Or start with this side and see if I can make it less complicated like, well, I'm gonna do that. We're gonna have 9 cosecant squared theta minus 7 cotangent squared theta equals 9 over sine squared theta minus 7 cosine square. Oh man, this is squared theta over sine squared theta. Correct? I just rewrote cosecant squared as 1 over sine squared and cotangent squared as cosine squared over sine squared. So now I can write them as individual, as a single fraction. And I'll write it over here. So now I have 9 minus 7 cosine squared divided by sine squared. Now, there's no fraction over here, so that means I need to change this up here so I get sine squared. Well, cosine squared theta equals what in terms of sine squared? Look at your Pythagorean identities. This is one they use a lot.
Cosine squared minus 1.
Nope. You want to write it as sine squared. All right, if you go to the initial one, which is sine squared theta plus cosine squared theta equals 1. I just want cosine equals what? So what am I going to do with the sine squared? Subtract it. So you're going to get 1 minus sine squared theta. Isn't it one of those in that long list of Pythagorean identities? I can't remember. Pull it up. Yeah. Is the second one down? 1 minus sine squared equals cosine squared. They just don't write it as cosine squared equals, they write it as 1 minus cosine squared equals the cosine. And then the next one down is switching the sine and the cosine. And then you have the tangent and secant ones. And then you have the cotangent and cosecant ones. But I'm used to seeing this as tangent squared plus 1 equals secant squared. And this is cotangent squared plus 1 equals cosecant squared. But, you know. All right. So now my numerator is 9 minus the quantity, or 7 times the quantity, because I'm changing cosine squared to an expression. So I'm putting it inside parentheses. So that's going to be 1 minus sine squared theta divided by sine squared theta. Multiply in by the minus 7. And so you get 9 minus 7 plus 7 times sine squared theta divided by sine squared theta. And you see the 2 coming into play here? 9 minus 7. So we have 2 plus 7 sine squared theta divided by sine squared theta. I don't have a fraction here, I have 2 things being added, 2 terms being added. Well, so I'm going to write this as 2 separate fractions. So that way I have 2 things I'm adding. So we have 2 divided by sine squared theta plus 7 sine squared theta being divided by sine squared theta. Well, right away, you can see we have sine squared over sine squared, so those go to 1. So over here, we're just adding 7. And this is just basically 2 times 1 over sine squared. But what is 1 over sine? Yeah, so we get back to the cosecant. So this is where we get the 2 cosecant squared theta plus 7, which is where we needed to be. And if I started on this side, this is, I would do the exact same thing, just in reverse. I would write this as 1 over sine squared, then I would write it as a single fraction. So I can see what happens there, so I'd wind up with this, which would give me this. The trick comes into seeing how I get from here to here. So I can bring the cosine into it. And I get in a hurry, my sign. The SIN starts looking really weird. Okay, any questions?
I was trying to understand when you were talking about the 24 to 21.
Yes. What about? (21 through 24?
Yes, okay, any way you can work them out,
Well, on the formula sheet,
or at least one of them. I don't care about the rest of them.
huh?
He said if you can work out just one of them.
Oh, okay.
Yeah, I'll figure it out from there. I just need to, I just can't visualize it right now.
All right, number 21. So you want to express the product as a sum. Product to sum. All right, what was the product? I forgot the product already. So here we have sine times, oh, they're both, oh, no, sine times cosine. So we had sine times cosine, so we'll use this formula. Sine of A plus alpha plus beta plus sine of alpha minus beta is multiplied by 1/2, right? So this is the formula we're going to use. So let me go back to the So that means we're gonna have, sine of 5 theta times the cosine of 2 theta is gonna equal 1/2 times the sine of 5 minus 5 theta minus 2 theta plus the sine of 5 theta minus 2 theta. So we have 1/2 times the sine of 7. Right, that was a plus here. 7 theta plus the sine of 3 theta. Boom, done. That's it. Right, and with sine times sine, you're gonna use that appropriate formula.
So you would just leave the answer like that then?
Right, there's nothing more to do with it.
Okay, so that's where I was getting confused at. I was trying to overcomplicate it then.
Now. Yeah. Yeah, that's it, we're done. And that what the answer portion says for number 21, right?
Yeah. that's what it
Yeah.
is.
Yeah, that's all we lined up. Boom, done. And so, yeah, all of those are just what's the appropriate formula? And then just plug um 7 theta in for alpha and 3 theta in for beta. Plug 8 theta, this isn't 80, it's 8 theta. And in for alpha and 4 theta in for beta. 4 theta in for alpha and 2 theta in for beta. So those are just a direct application of the formula and then simplify. Those are easy. Those are easy to 10 points. So you're gonna get one of these and one of these. And so that's 20 points right there. You're guaranteed on the exam. Because you just put the things in there, use the appropriate formula, and then simplify. The difficult ones will be establishing the identities. Because that gets a little tricky. And then it's just right setting up numbers 8 through 10. It's about setting up the triangle correctly so you can get all 3 sides. So you can rewrite the sine, cosine, or tangent appropriately. And same thing with numbers 5 through 6. It's what's that triangle? And more importantly, with 5, 6, and 7, you need to be concerned with what quadrant are we in. So. And same thing with numbers 1 through 4. I think there's gonna be some problems that are done similar to the way 1 through 4 are done. But the initial setup's gonna be a little different. So I need to look and see how much different they are. But it's just basically following the same pattern, it's not following the same rules. And then establishing the identities, yeah. So let me see what numbers those are. So from numbers 11 to 17 are just the trig identities, making one side look like the other side. Just like on number 15, you're just gonna have to say that it's the function equal to the other function and then establish the identity. And numbers 18 through 29, I mean 18 through 20 are pretty much are very similar to this. But you have to do an additional step. So they want you to find what cosine of twice that angle is. And so realizing you're starting in this quadrant, where is double that angle gonna make you end up? And you're finding cosine. And so if you wind up in the second, all right, you're in the second quadrant. No, you're in the first quadrant, and doubling it will put you in the third quadrant. And so cosine of 2 theta will give you a negative value. So that's something you need to consider. Cosine, where is cosine negative? Well, cosine is negative in this quadrant. This is the second quadrant. And when you double this, where do you wind up? When you double it, depending upon it will wind up either in the third or fourth quadrant. So doubling this angle, so cosine will be positive or negative. So you need to be very careful there where you're going to wind up. And that's a sign change, and because cosine is negative in the third quadrant, but positive in the fourth quadrant. And so where this winds up is very important as far as the sign is concerned. What you get for the cosine of 2 theta, it'll just be a difference of sign because of the symmetry of cosine across the x-axis and the y-axis. So in all three of these, you're going to set up a right triangle in the appropriate quadrant. I don't know why they're saying cosecant greater than 0. Oh. The cosecant of this same angle, it will be positive. So where secant is negative is the third and fourth quadrant, but cosecant is positive in the fourth quadrant. So this is gonna be in the fourth quadrant. And if I double that angle, because now it's gonna be a negative angle. When I double that, I'm gonna be in the third quadrant, and sine is negative down there. Tricky that one is. So it's just coming up with the appropriate ratios. I would rewrite this as sine theta of 3/5. And I'd rewrite this as cosine theta is negative. And I already rewrote this one, right? So then I can draw the right triangle in the appropriate quadrant. So cosine is negative over here. And cosecant or sine is positive here and here, so we're talking about this quadrant. And so, yeah, so we're talking about this angle. Where this side is 3 square roots of 5. And this side is 5, and then we just need to find this side. And then we have the appropriate numbers to put in for the formula for sine of 2 theta. Which is 2 times sine cosine, isn't it? All right. So square root of 5/3. Okay. My head, that's just not working out right. Because I would, yeah, and then I would, first of all, I would rewrite this as a negative square root of 5/3. And that would make this a 2 over here. And then go from there and plug those numbers in appropriately. Okay, I believe that's how I did it previously. And unless you have questions for me, I'm done with you. I know I didn't work one of those 19, 18, 19, or 20 direct all the way out. But once you can find, you know, sine is 2/3 and cosine is a negative square root of 5/3, and then you just use the sine of 2 theta formula and you plug those numbers in appropriately to get your result. Please, if you have a square root, leave it as a square root. I want exact answers. Exact value means you're not going to punch this into the calculator, square root of 5, because then you're approximating. I don't want approximate, I want exact. So you need to be able to manipulate square roots. So unless you have questions for me or comments or concerns, you're free to go.
All right, see you for the test on Wednesday.
Yep. If you're normally in class, you have the option of, like last time, either come to class to take it, or, but if you come to class, bring a computer or something you can pull the exam up on. Because I don't have a printed copy of it, so. Yeah, bye. See you Wednesday. See you on Wednesday. I'm going to unpin my screen. And change my view to gallery. And turn off the projector. All right. So unless you have questions for me, we're done for the day.